Alright, right now we're going to explore the results in 3D. The first part, we're going to switch to a local view. Depending on your arcGIS Pro settings, the 3D view can be in global viewing mode. So, global viewing mode. So this is map view. Look at here, okay? And then global and local view is grayed out. And if you go to scene, you can do local and you can do global. So, and local, and then global. All right. So, so depending on your ArcGIS Pro settings, the 3D view can be in global view mode, which means that the data is being reprojected to WGS 84 for this dataset with a projected coordinate system and a limited area of interest. We should work directly in this native coordinate system in a 1983 state plane, Pennsylvania South. Continue working from the map. We're going to link to the view to have them docked horizontally or vertically. We can continue that way. Otherwise, we can unlink the views and click scene to make it active map. So scene, this is activate map. We're going to turn off the robbery, this 3D layer, and make the robbery 3D layer visible. Hotspot layer, turn off this one and make it this one visible. Alright, and we're going to view the tab and click local. There, local. Okay, this is local. View tab, local. Then in the contents pane, we're going to right click on scene and then change the coordinate system to NAD, right? Property and coordinate system, we're going to do NAD. Projected. Okay, projected. State plane. We're going to do state plane, Pennsylvania South. State plane, Pennsylvania South, 1983, NAT 1983, FAT 1983, international. Okay, US feet, 1983, US feet. Alright, and US feet. Okay, Pennsylvania. It should be down, Pennsylvania, South. Pennsylvania South, 3702. Alright, and then we're going to click OK. So the local views is used for areas of smaller geographic extent in a project coordinate system, or when representing the Earth's curvature is not required. And we're going to clip the extend. So, alright. On the extend tab, we have to right click on it again, bring it back, property, and go to extend tab. It's just slow. Just wait, just be patient. Extend tab, and this is just really weird. Alright, extend tab. We're going to click the custom extend option. Custom extend option, and we're going to select robbery 3D, robbery 3D, STC 3D. From the calculate from drop down list, and we're going to do check clip the layer to extend. Okay. Everything looks fine. The custom extent is calculated from the robbery STC underscore 3D layer. Clipping the extent of the view will help isolate the area of interest. So we're going to click OK. The map property are applied. You can see the map is still linked, that's why. Some weird stuff going on. The map property are applied and scene view is updated. You will add a new field so that you can assign it the appropriate time. So let me double check if I saved it. For the extent, perfect. I didn't get this. Let's double check again. I don't think it was properly saved. Right click on it again, go to property, choose calculate, and this is 3D, and check this again, click OK. Alright, so we go back to this and save it again. Okay, back to the scene, local, and right click on it again, double check. Oh no, let's render it again. Check. Click OK. And we're going to open the attribute table of the robbery STC 3D layer, and go to the pan option menu, and then we click fields view. So the robbery hotspots are all designated with time. So next we're going to enable time so that the hotspots can be included in animation. So we have to do that first. We're going to right here, and we're going to the pan option. I'll open attribute table first and go to the pan option. Going to check it out. Resize it. Okay, resize it. This is the pan option, and we're going to do fields view. And then after fields view, the robbery hop are all designated with time. Robbery, we're designated with a time. I don't see it yet, so let's just find out. Open this and go to the pan option menu. We did, and click fields view. Then the robbery hotspot are all designated. Robbery hotspot. Where is robbery hotspot? Robbery hotspot. Designate with time. Where is time? Time and exaggerate. Where is time? I don't see time. Time exaggeration. Pan option and click fields view. Alright. This is in 3D scene. That's fine. We are designated with time. Count time ID, start date, and that's the time. Step says close the fields view, and we're going to and the attribute table. Then we're going to change 3D visualization styling. Alright, let's go into do it. We're going to do that. We're going to use the standard or default symbology. The cube will separate as you get closer. The style of visualization is fine for some use cases. For example, it helps with column-based understanding of the data and helps to reveal any patterns that might be wrapped inside other items. We're going to hide the robbery STD 3D layer, and then I'm going to turn on the robbery STC 3D hotspots layer, and we're going to zoom in until we can see the time interval separate. We have to zoom in. I don't have to select anything. Go back to map and clear. Just zoom in a little bit more so we can see the time intervals here. We can do a full screen, and okay, and then back. Yeah, we can see the time separation, although this type of visualization works in some cases. In this mode, it is harder to understand the spatial coverage of the analysis. So in this case, we're going to re-symbolize the content so that the cubes are in fixed real-world size as flattened cubes that cover the spatial extent they represent. We're going to open the layer property of the Robbery STC 3D hotspots layer. Right-click on it and go to Properties. And we're going to go to the Display tab, and we're going to select Displays 3D symbols in real-world units checkbox. So display 3D symbols in real world units. And then checkbox, and then click OK. And 3D symbols display in real world units displayed a constant measurement sites. It's not showing up. Let's zoom in a little bit more. I don't see any changes. Oh yeah, there are some changes. So regardless of view distance, next we're going to change the symbology. I'm going to do one thing real quick. Go back to Property, Display Complex Textures. If I don't use complex textures, let's see. Complex textures. Oh, I like this view a lot better. Do not contexture them. Wow, this is cool. And next, change the symbology of the location to make them real world size so that they fit the physical space they represent. We can make this change by manually changing each symbol. Using attribute-driven symbology properties, if available on the feature class, or we can use the attribute-driven property settings with constant values. We're going to use this third option because it is easy to access from the symbology pane and will not change the legend in the contents pane. So we're going to right-click on this layer, and we're going to go to symbology. In the symbology pane, we go to the view pane option menu and click review connected attributes. So unique values, symbology, their view symbology by attributes. All right. And then what we're gonna do is there are some options here. We can play around it. So we're going to expand size. Select set width and height from the sizing mode and drop down list. Size is right here. And we're going to do sizing mode. Maintain aspect ratio. Let's see what is here. And that we have fields. And now it's all changes. We do not have the width and height. So expand the size, select and set aside from the sizing mode drop down. And click the narrow expression or click expression builder. So we just have to do the expression builder. In the expression builder window, we're going to enter expression 250 in the text box, and then we're going to click OK. And now we do have something that for height, let's see, we do not see height size. I don't see height for height. Use the expression builder and enter 50 in the text box and click OK. I even do not see height. Enable size range. Alright, there is a range and I don't need range field. Let's click the field again. Yeah, 250. Alright, the hotspots of the space and time cube adjust according to the value we entered in the size problem.